Hello, everyone. Good morning. I'm Brandon Biggs. I'm from Idaho National Lab. Like our previous presenters, I've also used Apptainer quite a bit. What I wanted to talk about today was kind of some of the utilities around using Apptainer as the core focus, but ways that we can enhance it, especially with the great software ecosystem kind of around Docker. So I wanted to present to everybody today, like creating Apptainer workflows with Docker Compose-like utilities. So for a quick roadmap of my presentation, I'm going to talk about the motivation for a Docker Compose-like utility for Apptainer. I will talk about some available options that currently exist, a potential solution. I mean, like most things in software, there's many ways to kind of solve a problem. I will then provide an example, and I will talk about some benefits. So there's a lot of text on this slide. I apologize. We definitely don't need to go over all of it, but I did just want to talk about some motivation. So I think this XKCD about containers does a pretty good job, right, of explaining why containers are so great. But Dave Godlove also talked about, kind of the history of it and did a good job of kind of filling some of those areas in. But like in this comic, they talk about, trying to build your own app, but rather than doing that, they were piecing two smaller phones together and gluing them together rather than using a tablet and building your own app. And then the kind of the joke at the end is you never actually learned how to write software, but rather glue stuff together that you don't understand. And a lot of us do understand kind of how those things work together. But as we work and continue in software, like we learn that software can be pretty complex. And those of us that are more on the system administration side or help users and aren't like so much the front end users of HPC, we might have more software experience, but a lot of our users, at least for me, don't really care so much about how to get software working all the time. They want the software to work. They might be writing their own input files or their own code that utilizes other files, but they may not have any actual experience or little experience or not the time really. They may want to learn, but they just may not have the time to kind of help run more advanced software workflows, right? So you've got to load a couple pieces of software and then your code then calls it in certain ways, and that can kind of be tricky, right? So that's where as everybody here is familiar with, containers are very helpful, but sometimes combining containers can also be a little tricky, right? You've got a database container, you've got a task, like a task scheduling container, and then you've maybe got a front end container, and then you've got a Python container. And I mean, you look at some of these Docker files or Docker Compose files, and they really blow up sometimes. And you pull it down, and it seems simple because you just run a Docker Compose up, and all of a sudden you've got 10 or 15 plus containers, and you're not like it's working, but you're also not really sure how it's working, right? And that's great for those tools that people may not care about. But as we want to kind of understand the workflow, but also then focus on reproducibility and shareability, like those understanding how they work becomes important, right? So like what kind of options do we have in the Apptainer space that isn't in the Docker space, right? There's a couple of options. And I'm sure that there's more out here that I missed, right? There's been a lot of work in this space. You've got Podman Compose, which is Docker Compose for Podman. You've got Singularity Compose, which was I don't know how much support it's currently gotten, but Dave talked about Vanessa. Vanessa, who worked on like Singularity Hub, she wrote Singularity Compose, which has been a pretty great tool that I've used. There's also Fuzzball from CIQ. There's Bash scripts, and I'm sure that there's more out there that kind of help this scientific computing workflow with containers, right? The hard part is that is whatever you're using agnostic. So Apptainer is a really great tool that we use at our facility exclusively, but as soon as we try sharing that with somebody, maybe at another lab or another university, maybe they use Podman or Shifter or Charlie Cloud, right? There's other tools out there that they may run into. So let's look at a potential solution for this problem, right? Something that isn't using just a specific tool that can rather be agnostic, but also kind of solve some of the same problems, right? There's an open source tool called Process Compose. This tool was built specifically for to be like Docker Compose, but for regular processes rather than Docker files. But it turns out that we can use that and adapt it to Apptainer, and it works pretty well. So if we look at some of the pros and cons of this tool, some of the first pros are that it's flexible, right? It can take advantage of HPC nuances and containers rather than only being focused on Docker. Like some of you may be in the same situation where Docker is great and you may want to use it, but due to some of the security requirements on your system and you're working on HPC systems, you may not be able to use Docker, right, for security reasons. So that's why this tool is kind of helpful. It's very familiar, very similar YAML syntax to Docker Compose. It's portable. It's like Apptainer in that you don't need root privileges, and it's decently simple. It's written in Go, and it's a pretty small binary. But there are some cons, is that it wasn't built with the idea of containers in HPC, right? It was meant for just running processes, which turns out that that's what kind of you're doing when you're running containers. But that is a con, is that it wasn't kind of rounded around HPC or containers. It's also not as mature or as concise as Docker Compose. It's also not a one-to-one swap. Very similar, but it's not perfect. And then it also doesn't kind of abstract away container or bash nuances. And I said that may also be a pro because a lot of people like having all of that control. I'm not a Docker person. I've used it quite a few times, but I definitely am more familiar with Apptainer in the HPC space. So, when Docker Compose does things that I don't, it just kind of does things automatically behind the scenes, that always kind of makes me wonder, okay, well, what am I missing here? Or what is it doing? If there's an error, how can I troubleshoot that error, right? So this kind of doesn't necessarily abstract away all of those little nuances that you might get with bash or bash scripts or containers in running those. So, but you may be wondering, okay, that kind of makes sense, but I need an example, right? So we're going to look at this example. It's a data science stack. I have users at Idaho National Lab that have done very similar things. What they want is a timescale database, and that's what we're going to be looking at here. They want a Jupyter notebook to do their code development, and then they want a front end to show people, right? They want to be able to show to other researchers or to management, et cetera, what is actually going on behind the scenes. And Jupyter Notebook isn't always the best for that. So we've got kind of three utilities in our little stack here that we want to set up. This is, again, a lot of text, but this is an example of what a Docker Compose might look like. I've tried to split it up just a little bit so that we can see each of the main containers that would get set up, each of the main services, right? The first one, of course, would be timescale. I'm not going to go through each of this, but here's your environment variables. You've got your container names. Then you would set up your Jupyter notebook. Here's the image it pulls from, container names, ports, et cetera, and then Streamlit, right? You're pulling from Python. You do a little bit of work to install Streamlit. Not too bad, right? But my users, and I'm sure other facilities users, would never be able to run this again because it's around Docker, right? So how could we convert this to something that would be usable through Apptainer? Well, let's look at Process Compose. Okay, this is just the first bit of it, but like I said, it is a little, you do have to be more explicit in it, right? So you've got some stuff here just at the top. I specify, this is my variable, I specify a container runtime, and this is where I put Apptainer. You could put Podman, if you wanted to, I guess you could put Docker. But then you have to be a little more explicit in some of the things that Docker Compose does automatically for you. So for example, as we pulled from that, we make a data directory, right? These are just kind of the processes that we run. We would make a data directory, we would make a Postgres directory, and then we would clone the repos, build the definition files, et cetera, right? If there was already a pre-built container, you wouldn't have to do those things, but you may want to customize your own container. So you would maybe pull from you would pull from the Docker Hub and then use Python 3.13 and then do some of your own pip installs, for example, right? But this is where you have to be more explicit in each of the steps, right? And I would argue this also helps a little bit with reproducibility in that you can see each step as it's running. Now, you may be thinking, I can do all of this in a bash script, and you're absolutely right. But there are some advantages in that you don't have to be, while you do have to be explicit here, you don't have to be You don't have to do all of your own error checking. You don't have to do dependencies, because otherwise you might have to check that, did this part of the script run successfully? Is that directory existing, etc. This does a lot of that for you. This is the last half of it where we actually set up each service. So as you can see here, I have a service just like in Docker Compose. I've got one called timescale. And I also have a specifies that it depends on a couple of things. I wanted to make sure that my data directories were successfully completed, my Postgres directories, etc. Right? I kind of have this dependency chain of things that need to happen so that my timescale database can start successfully. And the nice thing is that this is all running from your container, the Apptainer container that you built in the previous step. Right. So, here's the timescale database. It's got some dependencies. We set some environment variables. Same thing with Jupyter, right? It depends on something, and then we set up some environment variables, and then we do the same thing for Streamlit, right? And that's all there really is to it. Is just you kind of have some dependencies, which may not exist depending on your current environment, and then your actual services. Now, the benefit here is that I can send this to anybody else. And because I am very explicit in creating directories, building the definition files, or pulling from Docker Hub or another, I could pull from GitHub's container repositories or Singularity Hub, all of these things, you just have this one file and then the process compose binary, and you can set it up on an HPC system somewhere where you don't have administrative privileges and so on. And then this may not be something for everybody, but when you run it, you would do something like process compose, and then you pass it the file with the -f, and then you get a built-in terminal user interface right on your command line. Doesn't have to be used, but you can, where it shows the status of each of your processes, as well as the age of them, the health, and then the compute resources being consumed. So this is kind of a nice benefit to see if you want to see, where are things going wrong? Is there something wrong with my flow, or is everything running as expected? So, you can see kind of up at the top, you see the version, host name, etc. But then you can see the process IDs as well as the names of your processes that you specified in your YAML file. So, I've got one for building the definition file, building the CIF file, cloning repositories. That's nice, so I can pull directly from GitHub, and it's not, I don't have to specify that in a bash script that's ran outside of my Docker Compose file, for example. And then some of my other processes that completed or are still running, right? And as you can see here, Jupyter is still running, Streamlit is still running, and my timescale database is still running, all of which I want to still be running, right? And then you can also see down here some of the ports that it's running on as well. So in my last few minutes, I just want to talk about some quick benefits. Why would I use this over other tools? And I think you could argue these either way, but my arguments is that it has a low barrier to entry, right? You really have your full stack in just a couple of commands without administrative privileges, right? You would curl the binary for process compose. Unless you've already got it, then it's only two commands. You would then download or copy your process compose for wherever it's at, and then you would just execute your YAML file. And because it's so explicit, it should set everything up for you. And it does have a lot of similarities to other tools that already exist. If you're familiar with Docker Compose, it's very similar. If you're familiar with, Podman Compose or Singularity Compose, also very similar. And it's pretty portable, right? Because all setup code can be in the same file where, it will download, Git repositories. It will build definition files, things like that, right? Really, you can kind of group it all into that single file that's not limited to just kind of containers. So with that, I wanted to wrap up just a couple minutes early, see if anybody has any questions, and make sure everybody has time for a break if they, which I think is next. So, are there any questions?
Yes, and we appreciate that.
Yeah.
Questions here?
Yeah, hi, I'm Marco from Fermilab. A question is about portability of the tool itself. So which language is written? Will it work on different platform, or does it have any requirement?
Yeah, so it's written in Go, and I don't have a Windows machine to test it on, but I've run it on my Mac and Linux boxes. It has worked basically off the shelf, right? I was able to just curl the binary, and it was just fine. Now, obviously, if like the previous presentation from Anders on Lima, you wouldn't be able to just pull it off the shelf and expect Apptainer to work without doing some pre-work, right? But that's also something you could kind of build into your definition or your process compose file to kind of help do some of that Lima setup if needed, if that makes sense.
So yeah, I have a question. So would you be willing to write this up in the apptainer.org, user documentation?
Of course. Yeah, absolutely.
Yeah, so that, because I think, we often do get questions, say, oh, can we use Docker Compose? How do you do Docker Compose with Apptainer? And would love to be able to just point people to that.
Yeah, yep, absolutely. Would be happy to do that.
Great, thank you. Thanks a lot. Any more questions? We've got one more minute.
I'm not familiar with Singularity Compose, but what would be the difference between this and that one?
Yeah, Singularity Compose, from my understanding of reading through the documentation and trying to use it, is that it was supposed to be like a one-for-one of Docker Compose for Singularity. And Vanessa did a fantastic job with the tool overall. But some of the downsides that I saw, and this is not just of Singularity Compose, it's with Docker Compose, Podman Compose, is that often there's additional steps that may need to be done for kind of a full stack container deployment, right? Maybe you want to build the containers from a specific file, or you want to pull from a specific place. Oh, sorry about that. I had a timer set for this. This just allows you to do a little more with regular Bash or CSH, et cetera, or in Python. I mean, it gives you a little more flexibility is kind of my big pro for it, if that makes sense.